My name is Ryan Wang, and I will explain the X-ray photoelectron spectroscopy and mass spectrometry parts of our analysis. First, X-ray photoelectron spectroscopy, or XPS, is a technique used to analyze elemental composition and chemical states of materials, especially at the surface. In an XPS instrument, an X-ray source directs high-energy X-rays onto the sample. These X-rays cause electrons to be ejected from atoms in the material through the photoelectric effect. The experiment is performed in a high vacuumed chamber so that the emitted electrons can travel without colliding with air molecules. The electrons then pass through an electron energy analyzer, which separates them based on their kinetic energy. A detector counts the electrons, and a computer processes the data to produce an XPS spectrum, which reveals the elements present and their chemical states. Next, we analyzed rocket fuels using mass spectrometry. Methane-based fuel is used in SpaceX Starship, while kerosene-based fuel is used in rockets like the Falcon 9. Methane fuel, which is CH4, produces a relatively simple mass spectrum because it is a small molecule. The molecular ion peak appear at MZ16, representing the intact methane molecule. The base peak occurs at MZ15, corresponding to the CH3 plus fragment, with smaller peaks at MZ14, 13, and 12 from further fragmentation. In contrast, kerosene is a complex mixture of hydrocarbons containing about 10 to 16 carbon atoms. Because of this, its mass spectrum contains many peaks. A key pattern is a series of peaks separated by 14 mass units, which corresponds to repeating CH2 groups in long hydrocarbon chains. The most intense peaks typically appear at MZ43 and MZ57, which corresponds to stable propyl and butyl fragments formed during fragmentation. That's it.